The drill string seems like a relatively simple piece of equipment compared with some of the other items we use in rotary drilling. That's deceptive. In fact, it's one of the most expensive elements in the process. Keeping pipe joints in good condition is essential to successful drilling. This program deals with the care and handling of drill pipes. We'll start with cleaning. Dirt left between the threads of joints will stop them making up properly, so all threads and thread protectors have to be cleaned. That means getting rid of dirt and any old dope that's still on them. Use a stiff wire brush to loosen the dirt in the threads of the box, pin and thread protectors. Make sure you get rid of everything that shouldn't be there. When you've done that, wash the box and pin with a solution of kerosene or Varsol. You can also use soapy water, but you must rinse with clean fresh water and dry it afterwards. If you use diesel oil, wash it off thoroughly with soapy water, rinse with clean water, then dry it. If you don't, it will leave a slick film over the surface and dope won't stick to it. If that happens, the dope will wipe off with the first turn and you'll have a joint which isn't lubricated. Never use petrol for cleaning. It's too volatile and it's a fire hazard. When you're satisfied that all the surfaces that will be mated are perfectly clean, check them for damage. Check threads and shoulders carefully. If a joint is damaged, paint a red band around it near the shoulder of the box or pin and take it out of service. If the clean joints are in good condition, they're ready for doping. Use a stiff, round brush to apply the dope and make sure you use the right type of compound. It's a grey compound containing 40 to 60% metallic zinc powder by weight and not more than 0.3% active sulfur. Other types of dope are used for drill collars, casing and tubing, but it's very important to use the right one on tool joints. Using the wrong type or thinning the compound can lead to serious problems. For instance, if you used a regular grease or oil, the extreme torque that the tool joints are subjected to would squeeze the protective film out and you'd have metal binding against metal. This would create rough spots on the threads and shoulders called galls. A soft powdered metal like zinc resists this squeezing action and gives better protection for the threads. Another reason for using the correct dope is that you obviously need a certain amount of friction to help keep the makeup torque. If you used a slicker dope, you wouldn't need as much torque to engage the threads. Downhole, this could lead to serious problems like stretched pins and belled boxes. After you've doped the threads, screw on a thread protector, but before you put it on, make sure it's perfectly clean. If there's any dirt left in it, it'll be transferred to the doped threads, which you've just spent so much time cleaning. Just screw it on hand tight. If you tighten it too much, you could damage the shoulder. If you've put on enough dope and the protector's clean and not damaged, it should screw on smoothly. When you take off a thread protector or disconnect pipe joints, there's not enough dope left on them to give proper protection. So it's just as important to dope them properly again when the drill pipe's being made up. The compound should cover all the thread areas of the box. Use a round, stiff bristled brush to spread it over every bit of the mating surface. It's the shoulder area that creates the make-up torque, so it should also be thoroughly doped. Always make sure you've got enough metallic zinc dope for the job. If you don't use a good compound, threads and shoulders are almost bound to be damaged. If you run joints into the hole dry, this is what you'll get: galled threads. It's a type of fault that can't usually be repaired in the field, and it could lead to permanent damage. Anytime pipes are not on the rig floor, it's absolutely essential to have thread protectors on them. If you don't, threads and shoulders are exposed to all kinds of abuse. When you bring the pipe into the V-door, for instance, its shoulder can hit the ramp. If it's lifted carefully, it should be guided clear. But if it does hit the ramp, the thread protectors will stop any serious damage being caused. You have to take the thread protector off before you set the pipe into the mouse hole, of course. Make sure the mouse hole is always clean, and be careful as you lower the pipe into it. Most pipe failures occur in and just above the slip area, so when you're making a connection, do it carefully and correctly every time. With the pipe stationary, set the slips about 2.5 to 3 feet below the top of the joint. The driller can then let the pipe settle gently into them. Remember, there's a complete string of drill pipe hanging below the joint you're working with. That can weigh up to £250,000 pounds. If you drop the slips in place while the pipe's moving downwards, that weight will pull down on the pipe as the slips clamp against it. The pipe will stretch, and the slips will squeeze it in. The slip dies will cut notches in the pipe, and the string will be seriously damaged. If it's run into the hole in this condition, the weakened area will certainly fail. Now, the sequence of actions needed for making up and breaking out. Never use a single tong. Always use 2. Never use the slips in a locked rotary table to provide backup. The rotary table should be unlocked and free to turn. Inspect and clean the tong dies regularly. Set the tongs on their respective tool joints, never on the hard facing and never overlapping the opposing joint. Overlapping can easily damage the shoulder. When the pin's broken out, the driller maintains slight hook snubber tension, or, if using a top drive power swivel, the snubbing counterbalance system works to make sure it clears the box as it disconnects. When it's clear, push it aside right away so that it doesn't hit the box. When making or breaking the connection, it's safer to use an automatic spinning and torque wrench, sometimes called an iron roughneck. The saver sub is an expendable substitute that protects the pin end of the Kelly or top drive. Each time it's tripped, check it for damage or wear. Sharp threads is an indication of excessive wear. Check the shoulder for nicks and galls. This is very important because if there is any damage, it'll create corresponding damage to each box that's made up with it. If the sub-saver is damaged or worn, remove and replace it right away. Take the thread protector off the box of the next joint. Make sure the box is clean and dope it properly around the thread area. Always give a last swipe of dope around the shoulder. Getting the correct make-up torque is very important. To find out what it should be, multiply the length of the tong arm in feet by the number of pounds of pull applied to it. For example, a 4-foot tong multiplied by 4,000 pounds of pull equals 16,000 foot-pounds of torque force. Before you connect the pin and box, check the threads and shoulders again. If there's no damage, dope the surfaces and make the connection. When you're stabbing the pipe, stop it swinging before you lower the pin. This needs careful timing between the driller and the rotary helper. If the pin lands on the shoulder of the box, don't try to roll the joint in. Wait till the driller lifts the pin, inspect the shoulder for damage, and try again. Use the Kelly spinner carefully. It usually spins the pipe up too fast, which galls or burns threads. If the pipe's not properly aligned, the joints will wobble and bind, and that too will burn the threads. To torque down using rig tongs, position the tongs on their respective joints. Make sure they're outside the hard face area. There should be no slack in the cable or snub line of the backup tong. Always ensure that the rotary table is unlocked. If the rotary table is locked, this could damage the pipe body because the pipe will turn in the slips as it's being torqued. Torque down using a single constant pull, not a series of jerks. There should be a 90-degree angle between the tong arm and the pull line to make sure the torque measurement's correct. Check the joint with a torque gauge. The top drive pipe handler torque wrench provides a means for smoothly torquing the connection using two torque cylinders connected between a torque tube and lower gripping jaw. If there's not enough torque, the pipe will wobble when it's downhole. This will wear and break threads and could lead to a fishing job. Under-torqued pipe could also become over-torqued during drilling by the rotation of the drill stem itself. If pipe is over-torqued, that'll stretch the pin and could make the box bell downhole and cause permanent damage to the tool joints. Torquing up properly is clearly a very important part of the whole operation, and it depends on the type of pipe being used. A common type and size is premium 5-inch grade E-drill pipe, IEU, with NC50, otherwise known as 4.5 IF connections. Proper torque will vary because it depends on the type of joint, its condition, and the nature of the actual drilling operations. And what is there to look out for when using new tool joints? It's particularly important to use the proper torque. With new pipes, pins are only 2/3 as strong as boxes, and so they're less able to resist bending. The only way to make them equal in strength is through compressive loading of the mating shoulders. Torque values have to be calculated so that the box and pin members can carry equal loads. You'll find more information in the torque tables in API publication RP7G, Recommended Practice for Drill Stem Design and Operating Limits. New pipe is more easily damaged than used pipe, so it has to be broken in cautiously and given a chance to be work hardened. If it isn't, the pipe won't last nearly as long. Make sure that all your tongs, automatic torque wrench devices and torque measuring equipment are in good condition and measuring properly. Dope the threads and shoulders as usual, and for the first few trips, make the joints up slowly. In fact, it's a good idea to use hand tongs at this stage. The high speeds of spinning wrenches and Kelly spinners can cause galls. If the threads bind, don't force them. The thread crests are flat because they're new and they'll tend to wedge against each other. A little reverse rotation will free them and they'll fall into position for spin-up. Keep new threads especially clean and well doped during the first few connections. Tool joint tolerances are closer on new joints than on used joints. After you've torqued the joint up properly, break it out, redope it, and make it up again. The shoulders are particularly important. They are the only seal in the pipe when the joints are properly made up, so that's where the mud is trapped. If you see any damage on either shoulder, they won't come together properly. That leaves an open channel, and when mud is pumped through the joint at 3,000 pounds per square inch, it's forced between the threads and out through the shoulder. In time, the threads will erode so much that they can't hold. Rotary speed and pressure are the next important factors to look at. Rotating pipe at the wrong speed can severely damage it. As it rotates, it gets whipped from side to side in the hole all the time. Too much speed means too much whipping. At the same time, the bit is constantly hitting resistance as it crushes its way through the formations. It may only be very brief, but it's repetitive and causes vibration. If the pipe's turning too quickly, this vibration puts it under more stress as the shock waves it causes in the pipe intensify the strain of the whipping action. The result of all this is the creation of stress lines in the pipe wall, but not in the heavier wall of the tool joint. The tool joint doesn't flex, so that throws even more stress on the area of pipe nearest to it. The whipping and bending causes microscopic cracks. If it continues, they'll get worse and the pipe will fail. Those are the basics of pipe handling and maintenance. Let's just summarize them. Keep joints and thread protectors clean. Dope them well with the correct compound, 40 to 60% metallic zinc thread compound by weight. Never use the wrong type of compound. Always keep a good supply of it in stock. The shoulders make the only seal there is. Always check them for damage. Don't over or under torque. You could end up with belled boxes, stretched pins, and damaged threads. Dope your tool joints properly, and don't forget that last swipe of dope on the shoulder surface area. Always use clean thread protectors. Take the thread protector off the pin before you lower the pipe into the mouse hole. If it came off while it was in the mouse hole, it could cause serious damage to subsequent pins. Never leave more than 3 feet of pipe above the rotary table when you're setting the slips, and always stop the pipe before you place them. Keep tongs, rotary bushing, and slip dies clean and in good condition. Always use 2 tongs for make-up and breakout, or even better, use the automatic torque wrench if provided. Check the saver sub each trip. Replace it immediately if it's worn or damaged. When making up new pipe, dope threads and shoulders. Make the pipe up slowly, preferably with hand tongs. Use them only on the tool joint and never on the body of the pipe. Torque down properly. Break out the joint and make it up again following the same procedure. Never run pipe at excessive rotary speeds or with excessive pressure. And that concludes Section 1, Care and Handling of